Okay, sorry I got cut off right in the middle of problem 30. So this is the end of it. As you saw, I used this formula for number 30 and I plugged in the initial amount, the final amount. I plugged in 3 for time and I've been working this all out. So we got down to here where we have, if you look at my calculator over here, you'll see I have negative 0.1500 equals negative r. Now obviously they're both negative, so I can just divide by -1 at this point. So r equals 0.15. So really the answer to this problem is the car is depreciating at a steady rate of 15% per year. Now, by the way, cars do lose value rather quickly. So some cars lose value faster than others. If you buy a really good car, sometimes like a Honda or Toyota, you will not see that rate be so high. Some other cars you will not get as good of a rate of depreciation, or it'll depreciate faster. Okay, we got 2 more problems and we're done. So let me try to finish up this video. So moving on to problem 31, and again, if you're just joining me, you don't realize I don't have any room to work here, so I'm going to erase all of this now real quick a second, and we will do 2 more problems here and we're finished. Okay, so we're moving on to number 31. Okay, the half-life of a particular radioactive isotope of thorium is 8 minutes. That means it takes 8 minutes for you to have half as much. Find an exponential decay equation for this isotope in the form E equals that, where T is in minutes. Okay, so again, you don't have to really figure out what formula to use because they gave you the formula. So we're going to start with A equals E to the KT. Remember, this is a science formula for things that decay at a continuous rate. That's why we see the E. For half-life, again, Ms. Brewer and I have been talking about this. You can call A 2 and then make this 1, so you have half as much. Again, there's a lot of ways to do that. You could also, by the way, for time, I'm going to put in the 8. You could also put in A is 50 and Y is 25, A is 100 and Y is 50. As long as your Y is half as big as your A, you have a half-life, okay? Half-life. Now, at this point, I would divide by 2. So 1/2 equals e to the 8k power. Now, how do you get rid of an e? You ln both sides. So I would get the ln of 1/2 equals the ln of e to the 8k. Now remember, that just wipes out the e, so you just get 8k on the one side equals the ln of 1/2, because the opposite of ln is e. Now you would just divide by 8, and I believe we will be at our answer. So k is equal to, now I need my calculator, the ln of 1 divided by 2, close parentheses, and then divided by 8. And I would get negative 0.08664. So basically my equation for this problem, it said write an equation for this isotope, would be, and I'm just going to erase a little something here so I can write it out real nicely for you. So basically the equation would be y equals AE to the negative 0.08664t. That would be an equation you could use where you can plug in how many bacteria you have in a time, and it will tell you how many you would have left. Okay? It didn't ask us to go ahead and do anything with that. It just wanted the equation. And so the final problem, and we are done, guys, is let me erase all of that now. Again, you can always pause this video if you want to go back and see what, or go back to it. My very final problem would be the one for a certain strain of bacteria, K is 0.872. When T is measured in days, if it's in days, then the whole problem will be in days. How long will it take 9 bacteria? So again, we got the same formula here, y equals AE to the KT. we're starting with 9, so that's the A, and it's increasing to 738, that's my Y, e to the 0.872t. Now we have to solve this for t. This is where we're going to need our logs or logarithms. Okay, so I divide by 9 on both sides, and I get e to the 0.0872t is equal to 738 divided by 9. So I get 82. Okay, now how do you get rid of an e? You ln both sides. I'm actually going to switch a color here. So I'm going to go ln and ln. So I would get the ln of 82 equals, and remember these cancel each other out, so you just get 0.872 times t. And then I'm going to divide both sides by 0.872. And at this point I just need to grab my calculator again. So I do the ln of 82 divided by 0.872, survey says 5.0536, I guess, or something, I don't know. Anyways, so remember that's in days, so we're looking at about 5.05 days would be my final answer to that problem. So it'd take about 5 days for that bacteria to decrease all the way down to, or increase to 738. Okay, and again, remember this has a lot to do with coronavirus and all the stuff we're dealing with, because COVID-19 is a virus, and it has been increasing exponentially. That's why we had to do the whole stay at home, to sort of flatten that exponential curve. Okay, hope you're well. That is the end of the review. It took me about 37 minutes total. Again, feel free to just jump around and see the parts you need. Have a great one.